Welcome to JavaScript section. In this section, we learned about one of the most popular programming languages over the world. The content of these sections includes the first, what is JavaScript? Give you an introduction about programming language JavaScript. The second, variables and data types. Give you a concept of a variable, how to manipulate them, and data types that JavaScript supports. Third, JavaScript functions. You will learn how to write a function in JavaScript and how to use it. Fourth, JavaScript events and coordinates. In this content, you will become familiar with JavaScript events functions as well as coordinates used to position or move HTML elements. Fifth, Libeless open layers. The two most popular JavaScript libraries for developing geospatial web. Let's get started with the first content. What is JavaScript? JavaScript was created and released to the world in 1995. It is an interpreted, dynamically typed scripting language that was initially developed to help bring webs to the life with the interactive elements and animations. JavaScript does not have a compilation step. It's turned into virtual machine code when a web page or application is loaded. Since JavaScript initial release, it has become one of the three core technologies of the World Wide Web, along with HTML and CSS. Over 97% of the websites on the internet use JavaScript, and all major browsers have a dedicated JavaScript engine to handle the language. JavaScript was built for the internet, and modern web designs would become completely different without it. While JavaScript is primarily run in browser, it can be used in backend and mobile app development. JavaScript is the programming language for the web because of some aspects. The first aspect, dynamic web page. JavaScript allows developers to create dynamic and interactive web pages. When you visit a website and see elements like slider, pop-up modals, live search suggestion, or real-time updates without refreshing the page, it's often thanks to JavaScript. The second aspect, client-side scripting. JavaScript primarily runs in the browser. It enhances user experience by enabling features like form validation, animations, and responsive designs. Third aspect, syntax and basics. JavaScript has C-like syntax, similar to Java and C++ programming language. Fourth aspect, frameworks and libraries. JavaScript has rich ecosystem. React, Angular, and Vue.js for building robust web applications. jQuery for simplified DOM manipulations. Node.js for server-side JavaScript. Fifth aspect, browser compatibility. Almost modern browsers support JavaScript. Developers write code that work across different browsers. Sixth aspect, security consideration. While powerful, JavaScript can also introduce security risks. For example, cross-site scripting. Developers must follow best practice to prevent vulnerabilities. JavaScript can update and change HTML and CSS through document object model manipulation. Thus, document object model represents the structure of an HTML document, and JavaScript interacts the document object model to change the contents. For example, update text and image, modify styles, for example, change colors and fonts, handle events, for example, buttons, clicks. JavaScript supports calculations by providing number types, operations, and math functions. JavaScript uses double precision floating point formats to represent numbers, follows the IEEE 754 standard. It supports both integers and floating point numbers. You can perform basic arithmetic operations like addition, subtraction, multiplications, and divisions. JavaScript provides a math object with various built-in functions for more complex calculations. In JavaScript, you can use regular expressions to validate patterns, for example, email address, phone numbers. For data validation, JavaScript do validates data in both client-side and server-side. In client-side, JavaScript can validate user inputs directly in the browsers before submitting it to the server. Common validation tasks include checking if required fields are filled, validating numeric input range, verifies email formats. In server-side, performed by the web servers after receiving input data, ensure the data's consistency and security. Remember that validation is essential for the data integrity and security. Whether you are building a calculator or handling user inputs, proper validations ensure accurate results and a better user experience. Next are examples illustrating JavaScript's capabilities. The area on the left is the source code of the website, in which the button tags contain the on-click events functions written in JavaScript language that change the contents of the p tags from old contents to new contents. Let's see. Continuing the previous example, in this case, JavaScript changed the values of the show attributes of an image. See? Turn on, turn off. In this example, JavaScript is used to change the style of the HTML elements. Specifically, the color style, fonts, and font size are changed every time the change style button is pressed. In the second content, we learn JavaScript variables and data types. First, let's make acquaintance with JavaScript variables. Variables in JavaScript act as named containers for storing data. They allow you to hold values like numbers, text strings, or other types of information. You can declare variables using three different keywords: var, less, and constant, or automatically declare. The var keyword was commonly used in JavaScript code from 1995 to 2015. Introduced in 2015, less keywords allow you to declare variables that can be reassigned. Variable declared with less keyword have block scope and must be declared before use the variables. Furthermore, the variables declared with less cannot be redeclared in the same scope. Also introduced in 2015, constant keywords declare variables with constant value. That means variables defined with constant keywords cannot be redeclared, cannot be reassigned, and have block scope. When you use a variable without explicitly declaring it, JavaScript automatically declares when it's first used. The following are using case of each keyword. First, always declares variables. Second, use const if the value should not change. Third, use const for the type that should not change, like arrays and objects. Fourth, use less only if you can't use const. Fifth, use vars only if you must support all browsers. JavaScript variables must have unique names called identifiers. Rules for constructing identifiers include: names can contain letters, digits, underscores, and dollar signs. Name must begin with letter. Names can also begin with $signs and underscore. Names are case sensitive. For example, Y's and capital Y's are different variables. Reverse word, like JavaScript keywords, cannot be used as name. Now, let's learn about data types. JavaScript has 8 data types: strings, numbers, big integers, booleans, undefined, null, simple, and objects. When adding a number and a string, JavaScript will treat the number as strings. Let's see the example below. The values of x variables has type of strings, not type of number. About evaluates expressions. JavaScript evaluates expression from left to right. Different sequences can produce different results, as the statements show. JavaScript types are dynamics. This means that the same variables can be used to hold different data types. The first statement, variable x declared. The second statement, x is a size value of 5 and has type number. However, the third statement, x is real size to string John's, and now variable x has type of string. The first data type, JavaScript strings. A string or a text string is a series of characters. A JavaScript string is a zeros or more characters written inside a quote. You can use single or double quotes. You can use quotes inside a string as long as they don't match the quotes surrounding the string. Templates were introduced with JavaScript 2016. Templates are strings enclosed in brackets. Templates allow single or double quotes inside a string. Note that the templates are not supported in Internet Explorer. Next is JavaScript escape characters. JavaScript will misunderstand the below strings. The string will be chopped to "we are so cold." To solve this problem, you can use \escape characters. The \escape characters turn special characters into string characters. Below are 6 escape sequences are valid in JavaScript: backspace, form fix, new line, caret return, horizontal tabulator, vertical tabulator. The second JavaScript data type, JavaScript numbers. Unlike many other programming languages, JavaScript does not define different types of numbers, like integers, short, long, floating points. JavaScript numbers are always stored as double precision floating point number, follows the international IEEE 754 standard. This format stores numbers in 64 bits, where the numbers is stored in bits 0 to 51. The exponents in bits 52 to 62, and the size in bits 63. About extra large or extra small numbers. Extra large and extra small numbers can be written with scientific notations using exponentials. Not a numbers. Not a numbers is JavaScript's reserved words indicating that a number is not a legal number. You can use the global JavaScript function is nan to find out if a value is not a number. Watch out for not a number. If you use not a number in mathematical operations, the results will also be not a number. Data types of not a number is a type numbers. Infinities. Infinities is the values JavaScript will return if you calculate a number outside the largest possible numbers. Divisions by zeros also generates infinities. Data type of infinity is type number. Next, JavaScript big integers. JavaScript big integers is a new data type since JavaScript 2020s that can be used to store integers values that are too big to be represented by normal JavaScript numbers. Let's see the example. To create a big integers number, append n to the end of the integers, or call function big integers. JavaScript booleans. Very often, in programming, you will need a data type that can only have one of two values, like yes or no, on or off, true or false. For this, JavaScript has a Boolean data type. It can only take the value true or false. You can use Boolean functions to find out if an expression or a variable is true. There are some cases need to remember. Everything with a value is true. Everything without a value is false. The Boolean values of zeros is false. The Boolean values of empty strings is false. The Boolean values of undefined is false. The Boolean values of null is false. And the Boolean values of not a number is false. JavaScript arrays. An array is a special variable which can hold more than one value. Arrays can hold many values under a single name, and you can access the values by referring to an index numbers. JavaScript arrays can be created by using simple square brackets and array items separated by commas. The following code declares an array called car containing 3 items: Saabs, Volvos, and BMWs. It is a common practice to declare arrays with the constant keyword. Space and line breaks are not important. A declaration can be spanned in multiple lines. JavaScript objects. Objects are variable too, but objects can contain many values. The values are written as name values pairs. Name and values separated by a colon. It is a common practice to declare objects with a constant keyword. The name values pairs in JavaScript objects are called properties. For example, first name John, last name Doors, age 15, eyes colors blues. Objects can also have methods. Methods are actions that can be performed on objects. Methods are stored in properties as function definitions. JavaScript undefined. In JavaScript, a variable without a values has the values undefined. The type is also undefined. Any variables can be empty. By setting the values to undefined, the types will also be undefined. Empty values. An empty values ignores undefined values. An empty string has both a legal values and a type. For example, let's assign empty strings to variables car. The values is empty, but the data type is string. Now, we jump into the third content, JavaScript functions. A JavaScript function is a block of code designed to perform a specific task. Functions are like a little programs within a larger JavaScript program. They allow you to organize, reuse, and modularize your code. Use the same code with different arguments to produce different results. A function is executed when something invoked. You can think of a function as a named container for a set of instructions. A function is executed once an event occurs. For example, a button clicks. It is called from JavaScript code. It is self-invoked, automatically executed. Declares a function using the function keywords, followed by a name and parentheses. Parameters or inputs of functions go inside the parentheses. The function bodies can contain the actual code to be executed. Using parentheses to call the functions. Incorrect parameters can lead to incorrect results. Not using parentheses returns the function itself, not its results. JavaScript functions returns. When you want to get the calculation results of a function, use the returns keyword. When JavaScript reaches a return statement, the function will stop executing. If the function was invoked from a statement, JavaScript will return to execute the code after invoking statement. Function often computes a return value. The return value is returned back to the caller. Functions used as variable values. Functions can be used the same way as you use variables in all types of formulas, assignments, and calculations. We have the two Celsius functions. Instead of using a variable to store the return values of functions, then, using it, we can use the function directly as a variable's values. Now, let's look at a few examples of functions in JavaScript. The first example writes a JavaScript program to get the first and Fibonacci numbers. Note, the Fibonacci sequence is the series of numbers 0, 1, 1, 2, 3, 5, 8, 13, 21, and 34. Each subsequent number is the sum of previous two. For example, the third number is the sum of the first number and second numbers. The fourth number is the sum of the second numbers and third number. This is the functions that generates a Fibonacci series up to the n terms. As you can see, we have the functions keywords, the function names, and function parameters. Inside the function bodies, we have the code to generate the Fibonacci number. This is the result when we run the functions. The first is the result when we run the functions with the parameter h. The second is the result when we run with parameter 10. And the last is the result when we run the functions with parameter 12. The second example writes a JavaScript functions that reverse a number. For example, we have a numbers 3, 2, 2, 4, 3, and the reverse numbers is 3, 4, 2, 2, 3. Similar to the previous examples, we also construct a function that reverses a number. And this is the result when we run the function. The third example, we will write a JavaScript function which returns the n rows by n columns identity matrix. This is the code of the functions that prints a square matrix with diagonal elements set to 1 and others to zeros also called identity matrix. And this is the result when we run the functions. The identity matrix of 5 rows and 5 columns was printed on the screen. The form contains JavaScript events. An event, in the context of web development, refers to an action that occurs within a web browser. When a user interacts with a web page, whether by clicking a button, hovering over an element, or pressing a key, the browser generates an event. As developers, we can listen for these events and respond to them by executing specific code. Web events are not part of the core JavaScript language. They are defined as a part of APIs built into the browsers. These events allow us to create dynamic and interactive web interface. There are various types of events that can occur. For instance, the user clicks, hovers, or selects an element. A key on the keyboard is pressed. The browser window is resized or closed. A web page finishes loading. A form is submitted. A video starts, pauses, or ends. An error occurs. To react to an event, we attach an event handler. An event handler is a block of code that runs when a specific event fires, usually a JavaScript function. When we define such a block of code to respond to an event, we say we are registering an event handler. The listener listens for the event, and the handler executes the code in response to it. An event handler, also known as an event listener, is a crucial concept in web development. It allows us to respond to user interactions and other events that occur within a web browser. The key points here are event type. Event type represents actions or occurrence within a web page. Examples include clicking a button, hovering over an element, submitting a form, or resizing the browser windows. Each event type corresponding to a specific action. Registering event handlers. To register an event, there are 2 ways. First, using onEvent properties. By convention, JavaScript objects that fire events have corresponding onEvent properties, named by prefixing on to the event's name. For instance, the onClicks properties handle the clicks event. You can assign functions to these properties to respond to the events. Only one event handler can be assigned for each event on an element. Second, using as event listener. This method provides more flexibilities. It allows multiple listeners to be assigned to an element, and you can add or remove listener dynamically. The event handler receives an object conforming the event's interface when events fire. There are some common HTML events: onChange, onClicks, onSmallOvers, onSmallOut, onKeyDown, onLoad. Now we see some examples for HTML events. The example 1 is for onChange event. The onChange event occurs when the values of an HTML element change. It is similar to onInput event but has a slight difference. OnInput triggers immediately after the value change, while on-change fires when the elements lose focus after its content has been modified. In these examples, you enter your names, and when you leave the input field, an events function is triggered, which transforms the input text to uppercase. This is the source code that implements on-change events. As you can see, we have on-change event handlers and the event functions uppercase. The example 2, we implement on-click event. The on-click event occurs when the user clicks on an element, such as a button's image or any other iterative parts of a web page. You can define the on-click events directly in the HTML elements using the on-click attribute. In these examples, when the button's drop-down is clicked, a drop-down menu was opened. This is the implementation code of example 2. This statement gets the buttons, and when the user clicks on it, executes my functions. My functions toggles between adding and removing the source class, which is used to hide and show drop-down contents. This example 3 on mouse over event. This on mouse over event in JavaScript is triggered when the mouse cursor hovers an HTML element. It is commonly used to detect when the pointers enter an element. In these examples, whenever you move the cursor over the gray rectangles, the numbers inside will increase 1 unit. This is the source code of example 3. There's on mouse over handlers and the events function. This example 4, on ski down events. The on ski down events in JavaScript is triggered when a key is pressed. It's a versatile event that works across various HTML elements where user inputs can occur. In these examples, press and hold down a key inside the text field to set the red background colors. Release the keys to set a green background colors. The source code of example 4. In these examples, we attach two handlers to the input tags, on key down handlers, on key up handlers, corresponding to two functions, key down function, key up function. This example 5. In these examples, write a JavaScript program that implements a form validation that displays an error message if a required field is left empty when submitting the form. This is the source code. In this source code, instead of using on event properties to register event functions, we use as event listeners to register event function. Next, we will learn about JavaScript coordinates. Coordinates play a crucial role when it comes to positioning elements on a web page. We will explore two primary coordinate systems: window relative and document relatives. About window relatives, these coordinates are similar to CSS properties positions with value fixes and are calculated from the top left anchors of the window, denoted as clients X and clients Y. They represent the positions of an element relative to the window. When the page is scrolled, window relative coordinates change as elements move across the window. About document relative, these coordinates are akin to CSS properties positions with values absolute within the document root, denoted as page X and page Y. They are calculated from the top left anchor of the entire document. When the page is scrolled, document relative coordinates remains constant. When the page is scrolled to the very beginning, so that the top left corner of the window is exactly the document's top left corner, these coordinates equal to each other. But after the document shift, window relative coordinates of elements change as elements move across the window, while document relative coordinates remain the same. On the picture, we take a point in the document and demonstrate its coordinates before scroll and after scroll. When the document scrolls, page Y document relative coordinates stay the same. It's counted from the document top. Clients Y window relative coordinates does change, and at the same point becomes closer to window top. Elements coordinates. The methods get bounding client rectangles return window coordinates for a minimal rectangles that enclose the elements as an object of built-in DOM rectangle class. Main DOM rectangles properties. X and Y coordinates of the rectangle original relative to window, width and height of the rectangles, and can be negatives. If you scroll the page and repeat, you will notice that as window relative button's position changes, its window coordinates change as well. As you can see in the picture, X and Y, width and height fully describes the rectangles. The right properties can be easily calculated from them. Left equal to X, tops equal to Y, right equal to X plus width, bottoms equal to Y plus height. There are obvious similarities between window relative coordinates and CSS positions properties with values fixed, but in CSS positioning, right properties mean that the distance from the right echoes, and bottom properties mean the distance from the bottom echoes. If we just look at the picture above, we can see that in JavaScript it is not so. All window coordinates are counted from the top left corners, including this one. Document coordinates. Document relative coordinates start from the upper left corner of the document, not the window. We can use the properties positions with value absolutes and top left to put something at a certain place of the document, so that it remains during a page scroll, but we need the right coordinates first. There is no standard method to get the document coordinates of an element. The two coordinate systems are connected by the formulas. Page Y equal to client Y plus head of the scroll out vertical part of the document. Page X equal to client X plus width of the scroll out horizontal part of the document. Canvas coordinates. When working with the HTML canvas elements, understanding the coordinate system is essential for positioning and drawing elements. The HTML canvas acts as a two-dimensional grid. The upper left corner of the canvas has the coordinates 0, 0. The x-axis increases horizontally to the right, and the y-axis increases vertically downwards. Each unit in the grid corresponds to the 1 pixel on the canvas. Elements are positioned relative to this original top left corner. In the sections of leaflets and open layers, we explore the two famous JavaScript libraries for developing geospatial web applications. The leaflets library is the leading open-source JavaScript library for mobile-friendly interactive maps, with just about 42 kilobytes of JavaScript. It has all the map features most developers ever need. The OpenLayers libraries. OpenLayers make it easy to put a dynamic web in any web page. It can display map types, vector data, and markers loaded from any source. OpenLayers has been developed to further the use of geographic information of all kinds. It is completely free, open-source JavaScript, released under the two-clause BSD license, also known as the free BSD. Leaflets libraries. Leaflets is designed with simplicity, performance, and usability. It works efficiently across all major desktop and mobile platforms, can be extended with lots of plugins, has a beautiful, easy-to-use, and well-documented API, and a simple, readable source code that is a joy to contribute to. This step-by-step guide will quickly get you started on leaflet basics, including setting up a leaflet map, working with markers, polylines, and pop-ups, and dealing with events. Step 1. Prepare the HTML page as pictured below. The second step, import leaflet libraries. The first, we need to include leaflet.cs files in the head section of your documents, using the link stack with the hyperreference attributes to point to the leaflet.cs. Next, we include leaflet JavaScript files after CS file, using script tags with source attributes to point to leaflet.js file. Now we put a div element with a certain ID where you want your maps to be. Make sure the maps containers had a defined hash, for example, by setting in CSS. Constructing the maps objects. Let's create a map of the centers of London with pretty OpenStreetMap types. From here on, we will be working in JavaScript. First, we will initialize the map with the set its views to chosen geographical coordinates and a zoom level. By default, option when creating the maps instance, all the mouse and touch interaction on the maps are enabled, and it has zoom and attribution controls. Note that the set view code also returns the maps objects. Most leaflet methods act like this when they don't return an explicit values, which allows convenient jQueries like methods chaining. Next, we will add a tiles layer to our map. In this case, it is OpenStreetMap tile layers. Creating a tile layer usually involves setting URL templates for the tiles image, the attribution text, and the maximum zoom levels of the layers. OpenStreetMap tiles are files for programming your leaflet map, but read the tile usage policy of OpenStreetMap if you are going to use the tiles in production. When we run the web page on browser, the maps of London cities is displayed on the web page. Next, we will create marker, circle, polygons and add them to the map. Markers are essentials for specific locations on the map. They can represent points of interest, cities, and any other relevant information. To add a single marker to your maps, use the else marker functions. You can customize markers' appearance, add pop-ups, and handle events associated with it. The first statement creates a markers and add them to the map. Circles, each overlays on the map, are useful for representing areas of interest, radius, or other spatial information. You can customize the circle's appearance by adjusting properties like colors, opacities, and fill colors. If you want the circle to be draggable, for example, for interactive purpose, you can enable editing for the circles. The second statement creates a circle in red and add it to the map. Polygons. Polygons is an overlays on the maps, are useful for representing areas, boundaries, and regions. You also can customize the polygon appearance by adjusting properties like colors, opacities, and fill colors. The array of coordinates defines the vertices of the polygons in a clockwise order. If you want the polygons to be draggable for interactive purpose, you can enable editing the polygons. The third statement creates a polygon and add it to the map. When we run the web page on browsers, markers, circles, and polygons are added to the map. As tile layers as base layers. When working with leaflets, you can easily add tile layers as base layers to your map. Base layers are mutually exclusive, meaning only one can be visible at a time. In order to achieve this, first steps, we separately create several tile layers, for example, carto layers, topography layer, Google Street Map layers, and Google Satellite layer. Second step, we want to group them together instead of adding them directly to the map. You can create a group layers to handle them as one unit. Third step, Libelus provides a convenience controls for user to switch between different layers on your map. You can use these controls to manage the base layers. There are two types of layer, base layers. These are mutually exclusive, such as tile layers. Overlay layers. These are additional elements you push over the base layers. Now we just add the group layers into the layer control. This is the source code. First, we import the libelus libraries. Second, we create map objects. Third, we create tiled layers with individual names, CartoDB files, Google Streets, Google Stars, OpenTopo Map, and then group them into a group layers named base layer. The last one adds group layers into the layer controls. Makes heat map with libelus. In libelus, creating a heat map overlays is a powerful way to visualize the intensities of the data points on a map. To create a heat map using the libelus heat plugin, libelus heat is a lightweight and efficiency heat map plugins for libelus. It uses the simple heat libraries under the hood and clustering the points into a grid for the better performance. You can make the heat map interactive by enabling editing or handling events. For example, clicks, mouse overs. Explore the libelus heat documents for more options and methods. This is the code for implement to make heat map. Similar to previous one, first we need to import lipless libraries. Second, we load the data from the APIs provided by GitHub, and then we parse the data. We create the base lipless layers, then configure and create the heat map layer. Determine the min max for the heat map plugin. Create the overlays lipless map using the two layers we created. And then add data to the heat map layers. We've done with lipless libraries, and now let's move on to the OpenLayers libraries. OpenLayers is a powerful and open source mapping solution written in JavaScript that can display multiple different mapping services on web page. What this means is that you can create a mapping tool using Google Maps and swap it with the used Bing Maps at a later date without having to totally rewrite your code. OpenLayers works by building up a series of layers that fit together to form mappings, tools, information, and events utilized like KML parsing and Ajax. Vectors and markers can also be used to add layers of the information onto the map. OpenLayer has several key features. First, tiled layer. OpenLayers can pull tiles from OpenStreetMap, Bing, Mapbox, Stadia Maps, and any other XYZ source you can find. OGC mapping service and untiled layers also supported. Second, cutting edge, fast and mobile ready. OpenLayer leverages Canvas 2D, WebGL, and all the latest gridness from HTML files. Mobile supports out of the box. Builds lightweight custom profiles with just components you need. Third, vector layers. Render vector layers data from geopositions, toppositions, KMLs, GMLs, Mapbox vector types, and other formats. Fourth, easy to customize and extend. Style your maps controls with straightforward CS. Hooks into different levels of the APIs. Use third-party libraries to customize and extend functionality. Quick start with OpenLayers. These primers show you how to push a map on a web page. The development setups use Node.js versions 14 or higher. The easiest way to start building a project with OpenLayers is to run these commands. The first command will create a directory called myapp. You can use a different name if you wish. Installs OpenLayers and a development servers. Setups a basic app with index.html, main.js, and style.js file. The second command change the working directories to your new myapp project so you can start working with it. The third command start a development server so you can view your applications in the browsers while working on it. After running npl start, you will use this output to tell you the URLs to open URLs http localhost port 5173 to see your new application. An OpenLayer application is composed of three basic parts: the HTML markups with elements to contain the maps, index.html, the JavaScript that initialize the maps, main.js, the CS style that determines the map size and others customization, style.js. Setups new OpenLayer projects. Opens the command prompt. project folders was created. Inside the project's folders, there are many files and folders, but only 3 files are important: index.html, main.js, and style.css. Inside the index.html files, the two important parts in the markups are the div elements to contain the map and the script tags to pull the JavaScript. The maps containers or targets should be a block of labeled elements like a div, and it must appear in the document before the script tags that initialize the map. In the main.js files, OpenLayers is packaged as a collection of ES modules. The import lines are used to pull in the modules that your application needs. Take a look through the API docs to understand which module you might want to use. The import style.js lines might be a bit unexpected. In this example, we're using the files at a development server. Files allows JS to be imported from JavaScript modules. If you were using a different development server, you might include the style.css in a linked task in the index.html instead. The main.js modules serve as an entry point for your application. It initializes a new map, giving it a single layer with an OpenStreetMap source, and a view describes the center and zoom level. Inside the style.js file, the first line imports the OL.js files that come with the OpenLayers package. The OL.js style sheet includes style for the elements that OpenLayers creates, things like buttons for zooming in and out. Now we jump into several examples of OpenLayers. The first example, we will display the tiled web map service on the map. Web map service can be used as a tiled layer, as shown here, or as an image layer, as shown in the single image web map service example. Tiles can be cached, so the browser will not refresh data for areas that were viewed already. But there may be a problem with the repeated label for the web map service server that are not aware of tiles, in which case single image web map service will produce better cartographies. This is the source code for display web map service layer on the map. The second example is about web feature service. This example loads new features from GeoServer's web feature service with a tiles-based loading strategy. Calling the use geographics functions in the OpenLayers projections modules makes it so the map's views use geographics coordinates, even if the view projection is not geographics. This is the source code of the examples. As you can see, the vector source gets the data from the GeoServer's web feature service, and then this data can be used to make the vector layers. In the example 3, we change tiles layer styles. When you want to change the styles of a web style layers based on some change in the application state, you should use the layers update style variables methods. Layers can be efficiently rendered even if the style variables are changed on every rendered frame. In case where you need to completely replace the style of a layer, you can call the layers setStyle methods. This method should not be called in response to frequent user events. This is the shortcut to change the tile layer styles. It's quite a long code. In the example 4, we use a custom style renders and a clip paths to render the flags of a country as a views for the country shape. This example 5 shows wind arrows styled using regular shapes for the arrows, shafts, and head. The shaft is scaled based on the wind speed, and the corresponding displacement is used to position the unscaled arrow's head at the ends of the scaled shaft. The weather data is provided by OpenWeather. The example 6 shows open data of subsidized photovoltaic installations in Vienna. Different style functions are used for clustering displays, single feature displays, convex holes of a cluster, and an expanded view of overlapping features. Hovering over the cluster shows its convex hole. Clicking on a cluster zooms to the extent of the containers feature. Clicking on a cluster consisting of features that are very close to each other reveals an expanded view of the features along a circle around the cluster. Features are styled differently depend on the power of the photovoltaic installation. Thus, example 7. In this example, show how to use both genders, events, and a vector's context to animate a marker's features along a line. In these examples, an encoded polyline is being used. The last slide will be dedicated to compare between OpenLayers and Lipless. OpenLayers provides maps in any browsing page with a greater number of features than Lipless, where maps are loaded from the different sources of the web page. This provides an interactive experience to users in the browsers. About Lipless, Lipless is mainly developed to support mobile applications with all the features supported for any online maps. User interface is made comfortable for any mobile users, making them know the geographical locations without any prior knowledge of the same. OpenLayers provides much flexibility to the user as it connects with different web pages. This helps users to check different sites and satisfy their mapping needs for any preferred location. But the application requires more storage space when compared with Lipless. While in Lipless, the applications do not require much storage in the mobile phones, and this makes users to install and use Lipless for their mapping needs. We don't have much flexibility while using Lipless, as we need to use the map storage inside the application. In OpenLayers, there are less numbers of plugins available in the application, but with the number of plugins, it's easy to collaborate with features in the system and use this for the further advanced mapping technologies. While in Lipless, with more number of plugins offered in the applications, there has been to be a problem of collaboration. Plugins do not work well together. That creates issues while using the application. In OpenLayers, plugins provided in OpenLayers are less as compared to Lipless, but the support is huge and flexibility to use any maps in the platforms make it worth it to try in either the browsers or on this mobile application. While in Lipless, various plugins are provided to users so that they can install and use several features in the mobile-friendly application. Also, the availability of map providers depend on the users as they can select any number of map providers in the application. The last comparisons. In OpenLayers, if more features are able to added as and when needed, OpenLayers are good for handling the requirements. Map projections can be done making the mappings more understandable for the common users. This also supports all of the Lipless functionalities. While in Lipless, if users are looking for a simple application with basic mapping needs, Lipless is a go-to application where users can use less plugins and use the applications with base mapping types, zooming facilities, and simple APIs. Plugins need to be used if the application is simple, thus making the users to work around with existing mappings application. From the beginnings, we have introduced to use all the basics of JavaScript as well as two libraries commonly used in geospatial web development projects. To be able to go further, these are just beginnings for you. You can refer to other sources to supplement knowledge and skills for your needs. Thanks for your attention.